So in this video, we're going to continue our work with square root property, but it's now the quadratic equations that are a bit more complicated. So take a look at number 5 here. So because we're going to be using the square root property, we still want to isolate x squared. So we are going to start by distributing this 3. Okay? And we're going to get that x squared by itself. So x squared plus 18x equals 81 plus 18x. And now notice that when you subtract 18x from both sides, that we now have no middle term. Okay? So we end up with x squared equals 81. And one of the things you should know about square root property is that it is really helpful when the quadratic is in the form of quantity squared, quantity or x squared equals number. Okay, so if that 18x had not canceled, then we would have had to have done something else or solved this equation with a different property or a different method. Okay, and those are the things we're going to do in future videos. All right, so here we are, x squared equals 81. So we have just isolated x squared. Now we're going to take the square root of both sides, use the square root property, and remember that plus or minus, right? So square root of x squared is x equals plus or minus square root of 81. X equals plus or minus 9. So our two answers are 9 and negative 9, as you know. Okay? All right, let's go to the next one. So this is what I was talking to you just about. See, and number 6, we have a binomial squared equals number, right? So quantity squared equals number. So anytime that we have a quadratic like this, then the square root property is really good method. So we are going to isolate the squared binomial. Okay, so in number 6, that's already been done for us, right? We've got the squared binomial by itself on the left, the number on the right. Okay, so we're ready now to go to the square root property. So, and again, we are going to remember that plus or minus. So square root of 5x plus 8 squared equals plus or minus square root of 9. So here on that left-hand side, the square root of something squared, you know these are opposite operations, so you're going to end up with 5x plus 8. Okay, these are inverse operations, so they undo each other, right? And then over here, square root plus or minus square root of 9 means we have plus or minus 3. Okay, so now this is important. We still have to solve for x because ultimately for these equations, when they tell us to solve, we're still solving for x, right? So at this point, we are going to split up our linear equation because we've got a linear equation here, right? This is linear. We're going to split that up into two different equations. The first equation is 5x plus 8 equals a positive 3. And then the second equation is 5x plus 8 equals a negative 3, right? So those two equations came from the plus or minus here on the 3, right? From the square root property. Okay, and so now we're just going to solve for x the way you know how. So we'll subtract 8. Here we get 5x equals negative 5, divide by 5, so x equals negative 1. Over here again, we'll subtract 8. Here we get 5x equals negative 11, so x equals negative 11 over 5. So those are our two answers, right? And again, we can check them. We can check them using our calculator back into the original problem. All right, let's go to number 7. So again, look at this guy. We have that squared binomial, right? We've got that quantity squared. Problem being that it's not isolated. So our first step will be to isolate that. So we're going to go ahead and add the 14 to both sides. It looks like 360. And then we are going to divide by 2. Divide by 2 both sides, so we get x minus 5 squared equals 180. And now we're ready for the square root property, and we got to remember that plus or minus on the right-hand side. So x minus 5 equals plus or minus square root of 180. Okay, so here with this radicand, this square root of 180, we need to pull out any perfect square factors, right? We need to try to find those perfect square factors of 180. So definitely I see the 9 in there, don't you? 9 times 20. And then 20 we know is 4 times 5. So the 9 and the 4, these are perfect squares. So we're going to take square roots of all of these. This is based on past work we've already done, right, in chapter 8. But good to review. So this is 3. So 3 square root of 9 is 3. Square root of 4 is 2. And you multiply 3 times 2, which is 6 root 5. So we get here x minus 5 equals plus or minus 6 square root of 5. And now we are going to solve for x. We have to split this up into 2 equations. So I'm going to have to come up here because I ran out of room. So we have x minus 5, here's the first equation, equals positive 6 square root of 5. So we go ahead and add the 5 to the other side. Okay, and so now what I want you to notice is that I'm going to stop here. That I am not going to add this 5 and this 6 to become an 11 because these are not like terms, right? We did that previous work before. So this is your final answer. It's an irrational root. It's got that square root of 5 makes it irrational. Okay? All right, irrational root. Number 2, the second answer, because again, we expect 2 answers, don't we? With a quadratic is x minus 5 equals negative 6 square root of 5. And again, we're going to add the 5, so x equals 5 minus 6 square root of 5. And again, we're going to keep the answers like this. This is another irrational root. And so our 2 answers are these interesting looking irrational numbers, right? By the way, we call these the exact answers. So sometimes in your homework, you may be asked to give a decimal approximation. And so you would then put these in your calculator and get a decimal. But these 2 are the exact answers to our quadratic. So I think we should check one of these, right? Good idea. Let's get that calculator out. Okay, so here we are at the calculator, and I'm going to use that Stokey again that I've used before. So I'm going to take one of these 2 answers to check. So I'm going to use 5 plus 6 square root of 5. And then I'm going to store that in x and hit enter. It gives me the decimal approximation, right? Okay, but now I'm going to go back to my original equation and type in that left-hand side. So 2 parentheses x minus 5 squared minus 14. Boom. And that's what I wanted to see. I wanted to see that if I substituted in one of my answers, I got the 446 that's on the right-hand side of the original equation. Perfect. Okay, let's go to the next problem. They're a little bit different, so let's look at these next problems. This one says solve by first factoring the left-hand side and then taking square root or using square root property. Okay, so x squared minus 4x plus 4. That factors us x minus 2 squared, right? Because we have 2 numbers that multiply to positive 4 add up to negative 4 is negative 2. Two of those, right? So on the left-hand side, we have what's called, I'll remind you, it's called a perfect square trinomial. Means that we squared a binomial to get it, right? So notice, do you see why? Well, can you guess why I wrote this as a binomial squared instead of just writing the 2 parentheses? If I could write the 2 parentheses, but then it doesn't look like our last problem, right? Where we had a quantity squared equals number. So now this looks like quantity squared equals number. And now we're ready to use our square root property. So we're going to take square root of both sides. We're going to remember the plus or minus on the right. So square root plus or minus square root 16. Okay, so here we get x minus 2 equals plus or minus 4. And then we're going to split this up. X minus 2 equals positive 4. Add the 2, add the 2, x equals 6. Or x minus 2 equals negative 4. Add the 2, add the 2, x equals negative 2. So those are my 2 answers, negative 2 and positive 6. Okay, let's go to 9. Okay, so this trinomial on the left looks pretty complicated, but it's a perfect square. Yep. What do we square here? We squared a 3x. What do we square to get a 16? We squared a 4. Our middle term is negative, so we need a negative. Okay, now let's check to see if we get the right middle term here. Well, remember, the middle term will be multiply 3x times negative 4, which is negative 12, and double it. There's 2 of those, and that equals negative 24. So we know that this is a perfect square trinomial. Remember that work we did before, perfect square trinomial. So it's okay for us to factor it like this. 3x minus 4 all squared equals 49. So now we're ready to take square root of both sides. Square root property, square root plus or minus, always on the right with the number, right? And so here we get 3x minus 4 equals plus or minus 7. So now we have 2 equations. One is 3x minus 4 equals 7, or 3x minus 4 equals negative 7. So we add the 4 to both sides. 3x equals 11. X equals 11/3 here. And over here we add the 4, but we get a negative 3. So 3x equals negative 3. X equals negative 1. So our 2 answers, negative 1 and 11/3. And I know that you know how to check this in your calculator. Okay.